Hi, I'm Dad the Engineer. Today I'm exploring the Creality Space Pi filament dryer. At the time of this video, the Space Pi is $66, and you can help me out by buying it with my affiliate link in the video description below. It won't cost you any more, but it will make me feel better about taking my time and energy to produce this video. Thanks. Before we get to the Creality Space Pi, I'll cover why you would want to use a device like this at all. Most common 3D printer filaments are, at least to some degree, hygroscopic. When a material is hygroscopic, it tends to absorb moisture, usually from the air. When you extrude filament that contains water, it boils in the hot end and converts to steam. Volumetrically, it expands about 1,700 times, which causes inconsistent extrusion in the form of bubbling, oozing, and stringing. This is not just an aesthetic impact, though, as it affects the layer adhesion and material properties too. Not all filaments are equally hygroscopic. Here's a list of common 3D printer filaments ordered from most hygroscopic to least. Nylon is the most moisture sensitive, requiring diligent storage and drying, while PLA is the least hygroscopic among the commonly used filaments. If you are unsure if your prints are affected by absorbed moisture, consider the following table. If the area where you store and use your filament has relative humidity below the figure above, for the type of filament you're using, you may not need to dry your filament at all. It is worth noting, though, that not all filament that you buy is already dry, despite being vacuum sealed. If you are over the humidity limit for your material, just know that your prints could be better, at least to some degree. To address this absorbed moisture, you can dry your filament. You can do this by lowering the environmental humidity, causing the moisture to move from the material to the surrounding air. This can be done through heating, lowering the water content of the air, or both. Filament can be over-dried, though the impact varies depending on the material. Over-drying typically occurs when filament is exposed to prolonged or excessively high heat, which can degrade the polymer structure. Here's how different filaments are affected by over-drying. As you can see, the material properties can change. The parts produced will be inferior to parts made with properly cared for filament. Also, the filament can break somewhere along the feed path, potentially ruining a part, wasting filament and time. The Creality Space Pi dries filament with heat and air circulation. It's not a very sophisticated device. It's a box with a heater, a hygrometer, a thermocouple or RTD, a touchscreen, and some rollers. The PTC heating element is touted as some kind of differentiator, but any heating element that is thermostat controlled should be fine. There's some PTFE tubing for running your dried filament directly into the printer feed path. I also appreciate that the Space Pi has a voltage converter on board and uses a standard C8 power cable. As far as a filament dryer goes, the Space Pi is fine. The performance of the unit is basically the same as any other heated filament dryer. The ability to select the material type is nice, as this sets the appropriate temperature. This effectively addresses the potential issue of overheating and/or overdrying your filament. Manual control is possible as well, assuming you have a filament that has other drying parameters. The controls are all on the touchscreen. The on-screen buttons are logical and easy to use, and will most likely be more durable than the membrane-type buttons on some of my other dryers. The styling of the unit blends well with Creality's K-series of printers, but would not appear out of place with nearly any other printer either. I use this setup with my Creality K1C, using the Space Pi in lieu of the spool holder. I recommend relocating the filament runout sensor to the side of the K1C if you use the same configuration. As a filament holder, the unit is decent. The rollers have a small radius, which can be an issue if you have any damaged spools. The build quality is alright, but the unit is lightweight, enough so that if you don't open the lid carefully, the unit can tip over. Aside from that, the unit isn't sealed, so you may need to run heat continuously if you're using nylon. My final thoughts are that the $66 purchase price is fair, especially if you pair this with a printer as a filament holder. I guess my main complaints with the unit have to do with missed opportunities. As it is, there's very little to recommend the Creality Space Pi over similar units from other manufacturers. Creality included a hygrometer in the unit's design, but they don't use it for anything other than displaying the relative humidity. Why not come up with an adaptive drying mode that uses a target temperature and humidity level rather than a temperature and a duration? Why not introduce an optional linkage cable for Creality printers to feed AC power to the dryer, but also pass dryer settings through Creality Print? You could also delay printing until the filament dryer humidity levels stabilize at a set level. Why not output the hygrometer reading via Zigbee so anyone that wants to set up automation workflows can do so? I'm currently faking this with a Z-Wave, AOTech multi-sensor, a LifeX light bulb, and a little work in HomeSeer. The light bulb changes color from red to yellow to green as the sensor approaches the target humidity level. Sure, this type of innovation can drive up the cost a bit. It can also make a commodity accessory into an essential component of a well-thought-out ecosystem. Printers and slicers are now working together more closely than ever before. Some printers can even identify filament with RFID and report back to the printer. What if the printer knew about the condition of the filament and could give some kind of estimate on the quality of the part to print, or possibly on the likelihood of a failed print? It's a logical next step in iteratively improving outcomes when using FDM printing. I guess that's for tomorrow. For today, I can recommend the Creality Space Pi dryer, but only so much as I'd recommend any other dryer that works just as well for the same price. And that's the problem with commodity level accessories, right? If you found this video to be helpful, please like and subscribe as I get this thing going. If you would like to contribute some feedback, please engage with me in the comments below. If you want a Creality Space Pi, please use the affiliate link in the video description. If, like me, you're a little old school, please check out my website linked in my bio. Thanks, and have an awesome day. In post, I realized I missed an important point. If you want the best part quality outcomes, you should be controlling your environment as well as you can afford to. Sure, improving filament characteristics will help, but having consistent ambient air control is important too. Temperature and humidity control through HVAC and dehumidifiers makes print quality better and more consistent. Something like that can be a limiting factor when putting an FDM printer into a garage, a shed, or a basement. I thought this was worth mentioning as I've seen plenty of setups in those environments.